Hi there, I've got a bit of a dilemma here. I'm not an expert in speaker crossover design or anything, but this looks wrong in the Oberon 1. This is the bits from it. I've taken out the capacitors that were here, C2, C1, and I've obviously you can see what the cement resistor values are there. These inductors I've measured with my meter here, and this is the circuit that I've got. So you have the tweeter there with the inductor across it. The inductor is this one here. It's only 180 microhenries. That's quite a low value, I would have thought. And then the capacitor coming off it is 3.9 microfarads. And this resistor here, 2R2, this is going to be to cut down the sensitivity of the tweeter a bit. So by altering that value, you can change the sensitivity of the tweeter, make it voice more or less. So this comes into the input there. Now this here is the woofer. These values here are what they actually measure with on my meter. So they're roughly about 6 ohms, 6 ohms. So this woofer here, obviously across it, there's an 8.2 microfarad capacitor. This 3.9 ohms is to do with the sensitivity as well. And the inductor is very, very low, 345 microhenries, that's very low. And this 0.39, I'm not sure what this is, but this looks like some sort of, don't know, some sort of feedback or something. I don't know what it is, but it's very, very low resistance there. It's virtually a short circuit between the in minus and the plus. So anyway, I looked up online at a few calculators, and apparently it's got 2,900 crossover. In fact, it's 2,800 according to the actual white paper from Dali itself, although a lot of places are saying 2,900, which is really high. Anyway, it's a second order crossover. I can see that because you've got two inductors there. But look at the values here. Linkowitz-Riley is one set of values, then Butterworth, then Bessel, then Chebyshev. They're all different types of crossover. But the values are well out. They're well out on everything. And I'm not sure what they've done to this. Obviously, the inductors, for example, on the tweeter there, 180 microhenries, and say a Butterworth, it should be 0.61 millihenries, which is 610 microhenries. So it's a long way out, long way out. I don't know why these values are so wrong. Here on the Chebyshev there, it's 0.31, so that's a bit more like it. But it's still a long, long way out. So I'm not quite sure what's happened. Obviously, with lower inductance values, it's cheaper because it's less copper. But I just can't understand. They're so far out. How can this actually work? I don't know. Anyway, what I'm going to do at the very least, I've bought some decent quality polypropylene capacitors to put in the position of the electrolytics I took out. That's always a very good upgrade. I'm going to have to mount these on a separate PCB because look at the size of the 8.2, which should go there on the woofer circuit. It's absolutely huge, this capacitor. There's no way it will go in there, you can see. So I'm going to have to mount these on a separate board, but I think if you replace the capacitors on here, I mean, there's non-polar electrolytics there, sounder. These are Chinese capacitors, so they're cheap as anything. So yeah, I'm going to mount these monocore capacitors. These are not the best, but obviously the best costs an awful lot of money, so I'm not going to spend too much money on this, but I think I should get a reasonable sound quality difference there. Obviously open core is very good. This value is wrong, I think. This is a laminated. It's not the same as, it's not ferrite core, so the laminators aren't so bad apparently. But yeah, this is a bit of a dilemma really, because what I would like to do is build a completely different crossover on a separate board, a much better quality one, which I can do, of course. Here's the speaker terminals, which I think are Chinese as well. It's not that great, is it really? But I might, I don't know what I'm going to do. I think what I might do, since these figures are completely wrong, I don't want to risk blowing up my woofer and tweeter there, so I might just start off by making an external board and linking them into here so I can see what the difference is on that speaker. The other speaker's unmodified as such at the moment. This is a speaker that's having the cabinets made up, so I'm going to sort out that first and see what the difference in sound quality is between this speaker and the other one that's unmodified. And I'll let you know in the comments what I find. I think what I'm going to do is take apart my Zensor ones as well, which are sitting nicely there, and find out what crossover components it's got, because this is completely wrong compared to all the different calculators. This is completely wrong, the components here, so I don't know. I mean, obviously this woofer is an SMC type, which might be different from the standard woofer. This is 29mm diameter, but it seems so far out, it's unbelievable, and it looks like it's a cost-cutting exercise here, but who knows. There's no contact number for Dali UK. I don't think they would talk to me about why they've designed a thing like this, but very, very strange. If anyone who knows more about crossover design than me can tell me what's going on here, that would be great. Thanks very much for watching. Please like and subscribe.